Couple examples with what we just did right here. I'm taking these straight from the book. You don't have to look in the book right now, but they're in there. And we got one like this. Okay, these two lines right here, they put little arrows there. That means what's true about those two lines? They're parallel. Good. So they say that this is angle Y, they say this is angle X, and this is 55 degrees. And they want you to solve for X and Y. All right, well, let's think about this. Which one do you want to do first?
X.
Let's do X. Okay, what's true about X and 55?
Equal to each other.
Come on, think first. They add up to 180. They form a straight line, right? They form a straight line. So how do I find X? 180 what? Minus 55, right? So that's 7, that's a 10, right? That's a 5, and that's a 2. So X is what? 25 degrees. It's 125. Forgot the 1. Thank you, Joe. All right, it's 125 degrees. Everybody good with that? That was pretty simple, right? We've done that kind of stuff before. Now here's something. This is really easy, but it's something that you needed to know this lesson to be able to do. What's angle Y going to be equal to? Look, I got two parallel lines. I got a transversal. What's the relationship between this and this? They're equal. Why? They're alternate interior angles. And what's true about alternate interior angles? They're equal. So what's angle Y? It's 125 degrees. As easy as that. Do we see that? That's the kind of stuff that you're looking for. You're looking to see if there's any relationships. Sometimes they're just right next to each other, and you look at it and you say, oh, it forms a straight line, it's a linear pair, whatever you want to call it. It's 180, right? Adds up to 180. So you find this angle right here by subtracting from 180. Then you say, oh, what's true about X and Y? Well, they're alternate interior angles. That must mean they're equal to each other. And that's what you do. All right? We good with that? All right, that was pretty easy. Let's do another one. Let's do this one right here. Let's have a line go like this, and then I'm going to take this line and, whoops, sorry. Try and grab it. There we go. Make it go like that, and it looks like the transversal is about like that, and this angle is 104 degrees. Do you see that? That one right here? And this one over here is X minus 10. Alright, and don't forget, you can't just assume they're parallel. You got to see. Alright, and they put little arrows there. And we want to solve for X. So let's see. Is there any kind of relationship between this angle here and this angle right here? Give me a name. They're alternate exterior angles. That's right. And what did we just learn about alternate exterior angles? They are equal to each other when the lines are parallel. That's right. If the lines are parallel, then the alternate exterior angles are equal. So we don't add them up and set them equal to 180 this time. What do? No, we do what? If they're equal to each other, we do what? We set them equal to each other. Say that with me. You set them equal. Okay. I know, but I want to know how to do I want to know the steps to do the problem. I don't care about just the answer. Okay? I want to know how we get to the answer. That's more important, okay? So we set them equal to each other because you look at this, you say, "Oh, that and that have to be equal." Why? Because they're alternate exterior angles. Set them equal, and now you can solve for X. So you add a 10 to both sides, and X is what? 114. Now you don't put degrees, because it's 114 minus 10, right, degrees. So it's not really X degrees, is it? Doesn't mean this angle right here is 114 degrees. So the answer is just 114. It just says solve for X. So it's really not a degree. Now on this one, is X a degree? Yeah, because X is the entire angle. Is this answer in degrees? Yes, because the answer is an entire angle. Let's do one more. We'll go to this nice purple right here.
How come some are like white on the corner?
White in the corner?
Yeah.
What are you talking about? Where are you talking about? Up here?
Yeah.
Oh, those right there? I think, don't know. What does that do?
Why does it matter?
Guys.
I'm not sure what that... Maybe you fill it up or something like that. So, Jesse, who are you calling stupid? Oh, okay. I didn't think so. Alright, here we go. Sorry, nobody watches these anyway, so... All right, here we go. This will be the last example, then I got to talk about one more thing. Okay, we got time, so just bear with me here. First of all, these are... No, they're not equal. What are they? They're parallel. That's an ugly arrow. Sorry about that. Now watch. This angle right here is 2x minus 15. It's that angle right there. All right, you see that? So it's in between these lines, so that's the angle it's talking about. And this angle right here is x plus 55. Let's take a look. These are parallel lines. This is a transversal. Is there any relationship between this angle and this angle? They're alternate interior, so they are equal to each other. So exactly right. So you set them equal. Very good. All right. That's supposed to be an x. Okay. So what do we put? 2x minus 15 equals, right, x plus 55. And now you solve for x. Let's do it real quick. Subtract an x from both sides. Add a 15 to both sides. So 2x minus 1x is x equals 70. All right? It's not at 70 degrees, is it?
No.
Because it's 70 plus 55. So what if they ask for that angle right there? What would you do?
Set it to, oh,
You go 70
minus
plus...
55.
No, come on.
Plus
Plus 55, right, which is what? 125 or something like that? Okay. There it is. Okay? Let's do one more thing, and we'll be finished. Don't erase it. Now I can erase it. Thanks. Alright, let's do one more thing. What if... Let's go back to black. What if I had parallel lines, two parallel lines, but watch my transversal this time. This time, I thought I was going to go to black, I guess. There we go. What if my transversal is like this? Okay. And what if that was 90 degrees right here? Right? We'll call that line L and line M. And this is parallel and this is parallel. That's right. All the angles are going to be 90, aren't they? Because watch, they're parallel lines. So this angle is going to be 90. What's this angle right here going to be? Give me a reason. That's right. They're corresponding angles. Exactly right. Because they're corresponding angles. This is actually another... Oh, you know what I forgot to tell you? You know those alternate interior angles are equal, alternate exterior angles are equal, consecutive or supplementary, all those things? We call that first one the corresponding. We called it a postulate. These other ones, though, are all taken from that postulate, and these are all called theorems. So if you look in the book, they're called theorems. Okay, it's just another word for a rule.
Students and teachers, when
Okay.
the bell rings for 125, please make your way directly to the Pusey Center for a pep rally, and then everybody will go back to their 7th period class. Middle school, you will stay in 7th period for the remainder of the day. Thank you.
All right, so now watch. This theorem, it's on the bottom of 180 if you want to look. It says, in a plane, if a line is perpendicular to one of two parallel lines. Listen to me. Don't talk. Listen to me. It says, if a line is perpendicular to one of two parallel lines, then it must be what? Perpendicular to the other. Exactly right. That's exactly what it says. Okay? So if it's perpendicular to one, it's got to be perpendicular to the other. Now, is that something that they had to tell us that we couldn't have figured out on our own? No. It's something that we could figure out on our own,
Mr.
isn't it?
Hammer,
Yes,
you have Anthony Perino.
I do.
He has an early dismissal.
Okay.
Thank you.
All right, so this is something that we could figure out kind of on our own. Same thing with alternate interior angles. Listen. Brett, up here. Same thing with alternate interior, same thing with alternate exterior, same thing with consecutive interior. Why is nobody looking at me? Okay, look at me, please. Everybody look up here. Connor, up here. All those things, we kind of figured out on our own, didn't we? When you can figure it out on your own, and you can kind of prove them on your own, that's when we call it a theorem. When we wouldn't have known one way or the other unless they told us, that's called a postulate. Okay? A postulate we just accept as fact. Theorems we can kind of figure out on our own if we really thought about it. All right, that's it. I'm going to give you a worksheet. Don't leave yet, Anthony. And then that'll be your homework. That'll be due next Thursday.